All aboard! Hello fellow CNC nuts and welcome. This week's project is last week's project. We're going to continue cutting the remaining parts out for our model train here. I also want to take a bit of time to address some of the questions left in the comments section on the last video concerning the building of the train, and then I also want to show how I made the toolpaths for it and did that 180-degree flip of the material to make the most efficient use of my stock. So it's about time we cleared the table down here, put some stock on the table and started some cutting. So the most common question I've been asked so far on YouTube, Facebook and by email is what sort of cutter I'm using to get the good finish on my parts when cutting plywood. And here it is here. It's a 1/8 inch single flute down cutting spiral bit. When cutting plywood, it's important that you do use a down cutting spiral bit. When these cutters run, they push the chips into the material at the same time slicing the fibers at the top of the plywood. Your usual up cutting spiral bit, what that does is it pulls the chips out of the slot, which is good for clearing the slot, but it also pulls the fibers up at the top of the plywood, which causes quite horrendous chip out at times. Now here's a piece that I've cut, and this hasn't been sanded yet. This is it as it is off the table, and there's the smallest amount of furriness there if you want to be picky. The back of it looks perfectly fine as well. There's no chip out on the back of this material either. So a down cutting spiral bit tends to push the fibers through the back of the plywood, but because it's sitting against the table, it doesn't cause that chip out that you normally see by using an upcutting bit at the top of the material. Now anybody interested in knowing where I got these cutters from, I'll put a link to the supplier I brought these from on my website, and I note with a bit of interest that they've actually come down in price by about 2/3, so that's pretty good. Back in 2015 I brought a packet of 10 of these here, and I've still got 7 of them left. The others I actually broke by doing stupid things like crashing them into the side of my stock or into my clamps or what have you. I don't think I've ever broken one of these here when actually cutting. It's just been when I've been jogging around. I'm sure there's a first coming for that. But they are solid carbide and they do last quite a while. So as I started cutting through the second sheet, I found that the cut quality had reduced. You can see here the furriness left on top. This isn't chip out, it's the fibers not being cut properly by the cutter. It's not really a problem, just a quick run over with the sandpaper, and it only takes a few seconds, and you can very quickly remove those fibers. And then you're left with the nice crisp edges that you should have. I found the back came out alright. Now I traced this down to the fact that the cutter had actually dulled over the course of my cutting. Now this isn't surprising given that I've been using this cutter for months before I even started this project. I did a test cut using a new cutter, and as you can see here, the results are much different. All these bits are nice and crisply cut at the top. They require no sanding. So it's not surprising that my older cutter had dulled a little bit. It's only to be expected. So the other question is, why did I use a 1/8 inch bit rather than a quarter when cutting the plywood? A quarter would have cut this out so much quicker. And the answer is it's because of these slots here in the project. Because these here have to fit like this here into there, these corners here, if I use a large cutter, would have large radiuses on them. The upshot is they just wouldn't fit together very well. By using the smallest possible cutter that's reasonable for the project, then I get this sharper corners in here, and so everything's going to fit together better. I found 3mm to be the best option for me. So here are all the components I need to make my train. I've already scaled the drawing as I showed in last week's episode, and the first thing I need to do with the drawing here is I need to select all the components here and come over here to join open vectors and have a check. I can see that I've got 442 closed vectors here, so I don't need to worry about that particular aspect of it. If they weren't closed, I would need to make sure that I went through and closed everything before I started. Whenever dealing with a file that you didn't create, it's always a good policy to go through and make sure that everything is closed. I'm also going to select this section of components here, go Control C to copy them, Control V to paste a copy of them there, and then I'm just going to move them up here, because these components here are meant to be made with material that's twice as thick as the rest of them. Since I don't have any inch thick plywood, I'm simply going to cut 2 lots of them and glue them together. After all, that's what plywood is anyway. Now the next thing I've got here is I've gone through and I've created my material size, 700 wide by 1200 long. So basically I'm just cutting my sheet 700 wide and keeping the full length of it, even though I cannot cut a piece of stock that big on my table. I can only cut to just over 1 meter in length. Now fortunately, this here, which is the longest piece in the puzzle, is only just a fraction over 1 meter in length, so I will be able to cut that in one piece. That saves me from having to tile this project. Now next what I've done is I've gone through and I've put the pieces that I want onto my cutting area here. So what I've done is I've taken these components here and simply dragged them off this area here and dragged them onto my sheet, basically wherever I think they will fit. This way I get to cut the components I want. In this case, this is the start of the train, the bottom carriage setup, which I want those components first. Then I'll select some of the others and build on that. I could use VCarve Pro nesting, but I find that doesn't work very well in my opinion. So I prefer to do this sort of thing manually. Now having these components laid out here, you'll note that not only have I gone up to my just over 1 meter in length, I've gone beyond there and put more components onto this sheet here. So if I reduce the size of my cutting area here to the actual cutting area of my table, you can see I can cut these pieces here fine, but I can't cut these ones or these ones here. But for efficient usage of my stock, I'm going to lay out the board as if I could cut the whole thing in one pass. Now all I have to do is select the parts that I can cut, which will be these ones here. I can now create a toolpath for them. This is basically just going to be a profile toolpath. I'll use my 3mm or 1/8 inch down cutting spiral bit. I'm going to set my feed rate to 50 inches a minute and my spindle speed at 10,000 RPM. I'll be taking a 2.5mm cut per pass. I will calculate this, and there it is. There's my toolpaths. Now these look a little bit close, but if I zoom in on there, and if I'll just go preview selected toolpath, you can see there that I will not be interfering with the other components, so I'm fine there. Okay, well that's the first toolpath done, but I'm just going to call this here sheet 1, cut 1. Okay, so now I'm left with these parts here to cut, the ones that are missing from the sheet. So what I'm going to do is I'm just going to hold down the shift key and select the entire board here, and you'll see what that does if I uncheck here is it selects the other pieces and unselects the original set that we're selected. And I'm just going to go create a new toolpath, a new profile, down cutting spiral bit, outside pass. I'm going to call this here sheet 1, cut 2. And I'll just calculate that for the second. But the problem is, that's not how I'm going to cut it. I'm going to select the whole thing here, come over here, and go rotate. I'm going to rotate it 180 degrees. I've done that. Come back over here to cut 2 and go calculate. Okay, you can see now it's going to cut these here at the bottom of the sheet. I'll just reset the preview. So you'll find that if you do enable the original cut 1, the two cuts overlap. So after I've done the first cut there, I'm going to rotate the sheet 180 degrees, put it back on the table, and cut the second toolpath there. This gives me full usage of my material, and I don't have to use a tiling toolpath. Again, it is important that you do a preview so that you can see if you have any overlapping cuts, and I don't, so I've got those spaced nicely. It just simply becomes a matter of saving these two toolpaths, and you need to save them as separate toolpaths. So just go save toolpath, save the first one, then select the second one, save toolpath, save that as a completely separate file. And that's the secret to doing a 180 degree rotation of your stock to make the most efficient use of your material. Well, there's no doubt about it. I think I must have been asleep when I made the toolpaths for these 3 wheels. Never mind, I'll cut them apart on the bandsaw. Now, at the conclusion of making these files, save it. I saved it as sheet 1, and then come down here and delete these components. They've already been made. We can now start putting more components onto our board here and laying it out. And we'll be calling this sheet 2. Need to bring these components in, rotate them as necessary, and put them onto the sheet. Position them so that you get appropriate spacing between them. You don't want them too close to one another. Try and get your spacing right. You can pick and choose which parts you want so that you can get the parts you need to start building it as it's going. That way you start seeing a result as you're putting it together. So just go through and just work your way through like this here, just selecting those parts. Just make sure you grab not only the outside but the internals of them as well. If they've got holes in them, make sure those holes don't move anywhere, and just take your time, lay them out. I'll just delete these here. And then once I've got the sheet pieces on the sheet here, then I can start making toolpaths for them. Now again, I'm only going to probably lay out these ones here first. I'll just go create a toolpath. There's my 3mm bit, or 1/8 inch bit I should say. I'm going to call this sheet 2, cut 1, calculate that. So there's my first set of components. Grab it like so. Sorry, I'll just then hold down the shift key, I should say, grab it like so. That selects these ones here. I will create a new one, sheet 2, cut 2, calculate that, then come over here, just grab the lot, rotate it 180 degrees. I'll just unclick those there. Okay, now just grab sheet 2, cut 2, and just calculate that, and you're done. Save each of these files individually, and once that's done, again, save this as sheet 2, delete these parts, and keep going until all these parts on this side here have been cut up, ready to go. Now, one of the things you'll notice is I'm not using holding tabs. There's a reason for that, and I'll go into that in my next episode. However, if you do wish to use holding tabs, and it's not a stupid idea, then simply put the holding tabs on here as necessary before saving your files. Well, there we have it, the finished train, and isn't it a beauty? 1.7 metres long, that's just over 5.5 feet. And I'm really pleased to see that the carriage here at the back is actually articulated. It's held to the train via a pin linkage, so that's going to make it easier to connect and disconnect for storage, as well as give it the best chance of being able to be motorised to run around my brother's front yard. Now, I won't be following up on that particular part of the project. I'll leave him to sort out the finer details on that. But if we get working, I'll put a video up of the train running on a track. Well, that basically rounds up this week's project. I hope you've enjoyed it as much as I have. I was really surprised how well this thing went together, how easy it was to make, and how much I ultimately ended up enjoying it. And I'm really pleased with the final result here. It looks beauty. Don't forget to check out the website here, www.makecnc.com. They've got not only these plans, but quite a few others, and hopefully you'll find one that you like and want to make. Don't forget to check out my own website, www.CNCnutz.com. I'll put a link in the description box below. Well, all that remains for me to do is to thank you guys for watching. Don't forget to like and subscribe, and hit that little bell symbol next to the subscribe button as well, and you'll be given instant notifications whenever a new video comes out. In the meantime, thanks for watching, guys. Cheers.